8214 covers arithmetic sequences in a linear function that can be written in the form f of x equals mx plus b, where x equals 0, 1, 2, and 3. Remember, arithmetic sequence is a sequence where you have addition or subtraction taking place. That is your common difference normally, and it's also representing your slope. In part A, it says write an equation in the form f of x equals mx plus b for the arithmetic sequence. They give us the sequence here. Sometimes it's easiest to go ahead and set it up as a table. Well, they're telling you here's our x values. So in your x values in your table, you have an x, you have a y. Well, here's 0, 1, 2, 3. This would obviously be term 0, 1, 2, 3. So we'd have 3, 7, 11, and then 15. Find that common difference in this. Well, the common difference here between each of these is plus 4. You are increasing by 4. So that increase of 4 basically is your slope. So that is your m value. That is what you write next to x. So we have our equation, f of x equals m, our common difference is 4. Write that next to x. And now we need to determine our b value. Our b value is the y-intercept. So a couple ways you can approach this. One way is if they give it to you, if you actually have to start with 0. Well, when x is 0, it's telling you that y is 3. So when you have a 0, 3 value, think of it on a coordinate plane here. 0, 3 is I'm going nowhere for your x-axis, and I'm going up 3 for y. So 1, 2, 3. Well, that's where that y-intercept, your b value is. So that b value is a positive 3. So I'd write down plus 3. So there would be our equation for the arithmetic sequence. The second way you could actually figure this out is actually put in values for x, which we've done before. So I put in 1 for x. When I put it in for x, 4 times 1 is going to give you 4. Well, how would you get to 7? Well, I would add 3 to it, and you'd check it for 3 of them. Well, if I put in 2, 4 times 2 is 8 plus 3 is 11. And then 4 times 3 is 12 plus 3 gives me 15. So that would be a second way to go ahead and take that on. Part B says, what is the 51st term in the sequence? Well, what you would do is, here's basically your first term, your second term. You would keep listing these out. Well, I wouldn't want to go up 51 places to figure it out. So what you want to do is you can't necessarily put 51 in for x, because x actually starts with 0. So what I do is if it starts with 0, I take out this first term. If you take out the first term, you would basically take 1 off of this. So then you'd say that it is the 50th term. So look right here. Here's term 2, which is essentially, I can put in a 1. Term 3, which essentially is a 2. So when I figure out my 51st term, it is really the 50th term. So I can put in 50 for x. And here's that equation that we have, 4x plus 3. So I would input in for x, I would put in 50. So I have 4 times 50 plus 3. And I wind up with 200 plus 3, which is 203. So the 51st term is 203. Equation 2, which equation can be used to generate the arithmetic example given? Then they tell you the values for x. What I would do is I'd go ahead and set up a table for this. So I would use 0, 1, 2, and 3 as mentioned for x, and then I put these little headers up here saying that this is going to be term 0, term 1, term 2, and 3 here. So next, basically what you need to do is put this in for x, and this is what I should get for y. Put this in for x, this is what I get for y. So you need to determine what equation that would be, and that would be equation B. If I put in 0 for x, I get out negative 7 for y. If I put in 1 for x, I get out negative 4 for y. Last one, I go ahead and the equation f of x equals 5x minus 3, which one generates the arithmetic sequence given for 0, 1, 2, 3, and then you need to figure out, well, what is the 31st term. So I'd go ahead and set up a table as well. I'd use the same approach as we did in 1b. Basically, your first term is 0, and you can't have a first term of 0. So we're going to take that out. If we're taking a term off, you're losing a term from 31. So you're going to basically have to put 30 in for x, and then you'll figure out your y value. So you'll plug 30 into your equation up here. So you have 5 times 30 minus 3. 5 times 30 is 150, minus 3 is 147. So our answer here is B. This will conclude 8214 arithmetic sequences.